Hello, mathematicians. This is Mr. Mailhot. Let's do some math. All right, you guys. I forgot to put on page 15 of your packet that this should have a video to go along with it. So my bad. Here's the video for page 15. We're going to look at our last topic that goes in this unit. And believe it or not, this is something you guys have done already in your balloon bungee project. This idea of scatter plots and lines of best fit. That's how you guys came up with your equations. Because remember how your equations, the way your bungees worked, it wasn't exactly the same difference in height each time. That's a scatter plot. And so on this page, actually, let's just get started. A scatter plot is used to investigate the relationship between two variables. In our balloon bungee, it was height and rubber bands. It could be anything. Scatter plots are really often shown on the news and in business because in real life, things don't happen exactly in a straight line very often. Also, those of you going on to maybe statistics in the future, either high school or college, or if you even just take the SAT in the future, scatter plots and lines of best fit, you'll see it quite a bit. So here's your first introduction, and you guys have actually already seen it before. Secondly, line of best fit is the line that kind of goes right through all the dots. But the way that the dots are aligned is called correlation. Correlation, or a trend, means how the points in the scatter plot are related to each other. So let's look at these examples. Now I apologize, mine here are a little blurry, so let's make this a little bit bigger. And I'll make it easier to see where the points are on here. For this one, you see how the dots are generally going in this positive direction? We would say that has a positive correlation. Your balloon bungees had a positive correlation because each rubber band you added, you could go up a little bit higher. For this example, the second one, I'll highlight the dots again a little better. These ones generally go down, and so this is called a negative correlation. Just because they generally they follow a negative slope. Now, this last one, I am even having a hard time seeing it. Let's do like a green. I'm seeing like some dots kind of just scattered all over the place. I might be missing some because my copy's real bad, but are they generally going in any given direction? No. We would say this has no correlation. They're not really related to each other. They're just scattered all around. We can't even draw really a line to go through them. You might think, well, yeah, Mr. Mailhot, we could draw a line this way. Maybe. You could maybe make an argument, but you see how far these are away? That's going to be hard to make a mathematical justification that you should draw a line there. All right, let's do some examples. And I like these because they're almost all can fit a real world example, okay? And if there's a trend in the data, if there's a correlation in the data, the line of best fit, those lines we drew, or trend lines, they can represent the data. So in this example, the data in the graph shows the resting heart rate of ages, so resting heart rate and ages of 24 students in an aerobics class. Graph the 4 equations on the grid and choose the one that best represents the data. Well, so heart rates and ages, those are your two, what did they say up here? Your two variables, right? And you see on the X and Y axis, there's heart rate and age. Okay, well, let's graph these. We'll do different colors: red, blue, green, and let's do like a pinkish color. Now you guys can use colors or just do it in pencil. But you can graph these the same way. Y-intercept of 80, so that means for this line A, you'd go up to 80. And the slope is negative 2/5. Now you got to be careful. Look at the axes, how they count. They're not counting by ones. They're counting by, I guess this would be by fives, and these are counting by fives. But we've talked about this before. If you go over down 2, and over 1, 2, 3, 4, 5. Even though the scale is counting by 5s or by 10s, this triangle or this slope is proportional to 2/5. They're just scaled up bigger. So we can continue to go down 2 and over 1, 2, 3, 4, 5, and maybe one more. Down 2, over 1, 2, 3, 4, 5. I'm a little off. I'm going to draw my best straight line between these. I got a computer so I can kind of do it pretty good. Let's straighten it out a little bit. Now, does that look like it's going through most of the data points? I don't think so, so I don't think it's going to be A. The slope looks about right, but not the y-intercept. Let's do B. Same thing, but different y-intercept. Here's 75, and down 2, over 1, 2, 3, 4, 5. Down 1, 2, over 1, 2, 3, 4, 5. I think that's enough. Let's draw a line through them. Now, to me, that looks more centered in the data. So this one, I think, might look good. Let's keep going. For C, that just says y equals 60. Remember, if it's just y equals, it's only going to go through the y-axis. This is going to be a horizontal line. It's one of those special cases. So we just have a line that goes this way. That doesn't seem right, does it? That doesn't match most of the data. It can't be C. Let's check line D. A slope of -3/5. It starts at the same spot, but it goes down 1, 2, 3, and over 1, 2, 3, 4, 5. Let's do another one. 1, 2, 3. 1, 2, 3, 4, 5. That's probably enough. I'm going to draw my best straight line. Now I'm going to have to straighten this out afterwards. But I think you can tell that doesn't quite, there we go, going through 75. That doesn't quite fit the data either. So the line of best fit from the options that we were given would be B. It fits mostly through most of the data. Okay? So which equation seems to represent the data the best? B. It cuts through the middle of all the points, all the data points. Remember, you can pause the video at any time. I just don't want to run out of time. B cuts through the middle of all the data points. Let's keep going. On the back side, you're asked to do basically the same thing. Now, there's some strategies you could use about looking at what's the same and what's different about the equations, like the slopes and the y-intercepts, but the foolproof way of doing it is to just graph the line and see which one best will fit through these points. Okay, if you get one that goes about like this, whatever one that is, that was a pretty good line. Whatever one that is, that's the one you want to pick. If you get one that goes like this, that's not going through most of the points, is it? It's not lined up, just like our balloon bungee stuff. All right, I'm going to end the video here. I'm going to put the answers to number 1 and 2 on this page. You're going to be in charge of doing 3, 4, and 5, and 6 on this page, and then there's a couple application problems on the next page as well. That's it for this week. I want to have you have time to finish up any of those other sheets that you didn't do, okay? So, remember, you learn and you get smarter by doing math, not just watching math. So now go do some math. Bye.